All right, part one, multiple choice. It says show your work and circle your answer. So question one is a series of limits. So the first limit is the limit as x approaches 0 of sine of 3x over cosine x plus cosine 2x. So the very first thing you want to do for any and all limits is you want to attempt direct substitution. That means plug in the value and see what happens. If the plugging in the value returns a real number, then that's the answer to your limit. If the plugging in the number returns a non-real result or an indeterminate form, the structure of that indeterminate form or non-real result may give you a clue as to what type of strategy you should employ to ultimately complete the limit. Now, one thing I want to point out, because this is a multiple choice section, you will notice that D and E and 0 is an answer choice for almost every single one of these. So it's the top two choices because it's the top two most commonly incorrect guesses that students make. So be very, very wary of a limit actually saying D and E. Don't just give up and write D and E. It's almost never D and E, and I can assure you that there is no problem on this practice final where D and E is an actual answer to the limit. So we're going to go through these one by one and show you kind of what to do. All right, so for this first limit, okay, I'm just going to copy the problem down so I have some room to work. So the first thing I want to try is direct substitution. So direct substitution would mean plugging 0 everywhere I have an x. So in the numerator, the sine of 3 times 0 would be sine of 0. Sine of 0 is 0. Cosine of 0 is 1. And when you plug 0 in here, you're going to get cosine of 0 again, which is 1. This works out to be 0 over 2, which is in fact 0. So that is a real result. So we would circle our answer of 0. For the next limit, if you attempt direct substitution here, what ends up happening is direct substitution is going to give you 0 over 0. Now, there are actually a couple of ways we can handle this. 0 over 0 is a L'Hopital. That unlocks the key to use L'Hopital as an option. And then the structure of this particular limit, when it's a polynomial over a polynomial, means you may or may not be able to factor. So I'm actually going to work this one out two different ways. So if L'Hopital is available to you, you are allowed to use it, but I would put this in the shortcut column. So you have to make sure you're explaining your work. So I'm going to demonstrate how to make sure we notate that properly. So here is our limit. Now, if your intention is to use L'Hopital, you want to first state that how and why you know you're allowed to use L'Hopital in the first place. So this limit has an indeterminate form of 0 over 0 when you plug 2 in for these numbers. So since that is in fact a L'Hopital situation, I'm simply going to indicate by writing LH here over this set of equal signs I'm going to write, indicating that between this limit and the next limit, I'm invoking L'Hopital, and that is what justified my decision making here. So with L'Hopital, we take the limit as x approaches 2 from the left. You take the derivative of the numerator over the derivative of the denominator. Then you attempt direct substitution again. If you get a number, you're done. If you're still getting an indeterminate form, then you may have to use this multiple times. So if we try to plug 2 in now, we'll see that the numerator gives us 4 minus 5. The denominator is 1, and this works out to be -1. So that's one way we could arrive at the answer of -1. Another option is we saw early in the semester that one thing you can do with limits of this type is attempt to factor, and hopefully the troublesome factor will cancel out. So if I take the limit as x approaches 2 from the left, I have a quadratic in the numerator. So I'm going to factor this, and it factors into x minus 2 x minus 3. This is over x minus 2. Now we can see that x minus 2 cancels x minus 2. That leaves me with the limit as x approaches 2 from the left of x minus 3. Now when I plug in 2, I get -1. So both return the same answer. Now, one thing that we will be looking out for on these when we're grading is the fact you're using proper limit notation. So a good rule of thumb with limits is as long as there are still variables in the equation, you must keep writing limit. You can't drop the limit until the direct substitution is successful. So when you're going to successfully get a number, you're plugging in, that's when you're actually doing the limits. You can think of limits as a math operation. And so everything we did leading up to plugging in the number successfully was either algebra or preparation or rewriting or reworking. So we hadn't actually done the limit yet. So make sure you're using proper limit notation when you're writing things down on the exam.